Did any of you download JDK, JVM? Anyways, have any of you downloaded JDK recently in the last class? Some of you actually did, right? So you saw the JDK download. What exactly JDK is? Java. Okay. Just like you have JDK, you have SDK, software development kit, Java development kit, you have ADK, Android development kit, all those things. Thing is, just like any other kits, we have all those sports kits, right? Cricket kits and badminton kits. What do they mean? What is a cricket kit? Except for the stadium itself, you have everything in that bag that you need in order to play the sport, right? You'll have bat, ball, and all those kind of equipment that you need. Same thing. All the things that you need to write a program and to do things, do experiments, all kind of experiments that you want to do with Java program, all those kind of tools are available in JDK. That's it. That is your Java development kit, right? So inside JDK, you have two things, two components. You have something called as JRE, and then you have something called as JVM. Let me show you the figure. Yeah. So this entire thing is JDK, right? And this thing is JRE, and the bottom thing, do you see this? This is JVM. So you can actually say JVM is part of JRE, and JRE is part of JDK, right? JDK is equal to JRE plus JVM. A simple equation to remember. JDK and JRE. You know what JVM does? It actually runs the bytecode. That is the core thing that actually runs Java programs on different platforms. That we know. But what is the difference between JDK and JRE? You just see a bunch of names here in the figure, but what exactly is the difference? The difference is, if all you want to do is just download a program and run, that's it. You are not a developer. You're just a client of a program, that's it. You're just taking a program, running it. You're not a Java developer. You don't want to develop. You don't want to write your own Java program. If that's the case, then you need not download your system. That is why the name Java runtime environment. That means all the predefined classes, files, and all the things that you need in order to run Java application, all those things are packed into JRE, right? But if you actually want to go ahead and write your own Java program, then you need tools like compiler, interpreter, and all those things. So all those things are actually present in JDK. That is why the name Java Development Kit. I don't know if that's visible, but this is Java. This is Java C. So Java C is nothing but an application that is nothing but your compiler that compiles your source code .java file, right? And sorry, and Java is nothing but your interpreter. Okay, that is also an application. Let me just go through and show you what these things are. Okay. Program files, Java. You see this JDK and JRE? So let's go into JDK. You can see the compiler and the interpreter. Did you see this Java C application? This Java C is nothing but your compiler, okay? And Java is nothing but your interpreter. So you basically use this application to compile the program. You use this application to interpret, to actually run your program. Okay, so this is JVM, and this is entire thing is JRE, and this is your JDK. So yeah, that is all. You can anyways I'll forward the slide so you can actually refer if you want to know more things about these things, which thing includes the location where Java C and Java are. So because command prompt is Windows own application, so you actually go into the advanced settings and all those things. So if you don't know, again, I'll forward the slides with the, let me just properties, advanced system settings, environmental variables, and then you actually have to add a variable called as Java path, and then you have to give the path of the bin folder that I just opened. So again, that is just all this thing is just a way to link your command prompt to Java C and Java, those two applications. That's it. Okay, and all the other applications that you use. That's the reason you give the folder bin. Bin includes all. And if you didn't understand what I just said verbally, I'll forward the presentation so you can follow this slide. I think it's actually pretty clear all the time. So yeah. Apart from that, you have to know the classical way of compiling and running a program, right? Because if you're someone who worked on Java, then and the point is, I can tell for sure you'll never probably run. Yeah, yes, sir. So yeah, that was a break. Do you guys need a break? No, right? So anyway, so the whole point is you'll probably never use an IDE. Do it after. I'm not asking you to do it in this class. You can refer the video and you can practice at home or anything. So just watch what I'm trying to do. Just open a new file, okay, and then write this public class demo. Let me just change. Okay, as I said, first thing you have to know is a Java program always has a class. First thing you'll do is you declare a class, you write a class, right? So with that you declare with the keyword class, okay? And then you write a name, whatever name you want to give, you can give. But the thing is, again, I'll explain that later. But again, for this point, every Java program will have at least one class. There cannot be a Java program with 0 classes. It's just not possible. It can be possible in C, but it's not possible in Java, because Java is object-oriented. Everything, whatever you do, should be inside of a class. Okay, you can have any number of classes. There's no limit. You cannot say that this file should only have 1 class or 10 classes or 100 classes. You can have any number of classes, but that's just not a good idea to pack all the classes into just one file, because it's just not clear, readable. So it's actually a good idea to place all the classes that are related to one specific thing in one specific file. Again, I'll come to that later. I should have open the brace and close the brace. So all that you want this program to do goes inside this block. it as what? Private, and then you have two more access specifiers, G for protected, and all those things will come to that in later classes. But as of now, that's the whole point, to make the class public so that other program, because see, Java C itself is also another program, right? It's written in Java, but then still it's a Java program. So you have to give that program access of this class. That you do by writing the keyword public. Again, just the keyword class and name. So now, you have two things in classes, okay? You'll always have two things in classes at this point. One is variables, and the other thing is methods, right? You'll always have two things. Those are actually called as class members, okay? So at this point, we are not going to write any variables or that thing, but we'll have methods. And this is the method that will be there in all the classes, main method, if you haven't already heard of this thing, main method. The reason is, this is the entry point for your program, okay? Once you run this program through a compiler, and when you want JVM to actually run this program, okay? See, when I'm referring runtime system, JVM, it all means the same. What I'm trying to do is, and what I'm trying to say is, just the JVM would be interpreter, which is running this program, okay, which executes each instruction, okay? So again, for each program, the entry point is main method. So every program will have at least one main method, okay? Main method, I'm not saying main method is the only way to enter into a program, but you don't want to know the other way, because there are actually other ways, but using other programming languages, like you can actually use JavaScript and all those things to make an operator and get into the program, but let's not get into that. As of now, main is actually the only entry point to start to get into a class. Okay, so that's the reason you got to have main, and whatever you want to do, you write inside of a class, and inside of that, main method. Okay, so now you have a couple of keywords that you have to add before main. Again, first keyword public for the same reason, because you want this method to be public. If you write private, then even though the interpreter can come inside this class, it cannot see this method main, because you said that this method is too shy to expose itself. So that interpreter cannot just access main method. So that's the reason you actually have to declare the method also as public, right? The thing about methods is it returns something. What does a method do? What does a method sum do? What does a method subtract do? It subtracts something. What does a method add do? It adds something. So a method does some kind of job, right? That is what a method is. It does some kind of job. Okay. So it usually returns something. For example, if you're writing a method to calculate two integers, then it will do variable 1 plus variable 2, and you'll have, and this method will return that sum. Again, things might not be crystal clear for you, but the whole point, I'm not even expecting that. The whole point of writing this program is just to give you an idea on how to compile and run a program. But just because shouldn't be entirely Greek and Latin, I'm just giving you a brief explanation of what these keywords are, but you'll get to know all these things in 2 or 3 classes. All right. So again, apart from public, you have 2 more keywords that you have to add for the main method. Those are static. I'll tell you what static. It actually has an interesting. It's not just because most of them actually get confused by what static keyword is, but it's actually interesting why static keyword is placed in the main method. If you guys are really interested, you can check out. But then I'll tell you in the later on classes what static keyword does is. And anyway, the other thing I've said is every method returns something. Okay. What if a method does not want to return anything? Void is, what do you mean by void? Empty, right? It doesn't return anything. So that's the whole point. So public static void main. This is the standard way of how you declare. I think the screen froze. Anyway, so this is the standard way of writing a main method as of now. Okay, public static void main, and then you have certain parameters that goes into the main method. Again, I'll tell you in the later classes what these exactly mean. this is actually a class string, and this is actually parameters. Okay, this is an array with the name arguments, ARGS, okay, string arguments. So I'll tell you what those things are. Okay, I'll explain you this line, but in order for that, we have to know what an object is. Only then I can explain what static keyword is. Just be patient. Once we finish the object, once you guys understand what a class and an object is, you'll understand most of the things. Forget about the complex things. You'll understand most of the things, but the only condition is you have to really understand what an object and what a class is. Okay, it might seem like two simple words, but they actually have a lot of concept behind those two words. That is actually the crux of Java. Okay, so again, just be patient. And then inside the class demo, you have a main method, and inside main, this is a method actually used to print. Okay, and then in inverted commas, you write hello world, and then you end the sentence. Okay, so the thing with print, or you can also write println. There are just different methods to print. Differences: println prints this thing, and if you have a more statement, it prints into the next line. So print new line is what the meaning is. And if you don't want to print on a new line, you can just have print. Those are the two different functions which do the same job but in different ways. Okay, one gives you an extra line, new line. One does not give you a new line. So yeah, that was the significance of ln. Anyways, so the thing is, this println method should be defined somewhere, right? I mean, this is a method that's fine, but it should be somewhat defined somewhere. So the point where it was defined was a class called system, and you cannot refer it directly, but through a print stream object called as out. It's a variable out. Okay, system out println hello world, right? So let's try and run this program. So the first step after writing the program is to save the file. Okay, just save the file. So what would be the name that we will give to this file? ydemo.java. So what if I have 10 classes in the first file? Any class name? Exactly. The point is, the class that has the main method, that class's name should be saved as the name of the file. That's just a convention, okay? So demo.java, and just put it on desktop and save. So let's go to the command. Let's see if the file was actually stored. Yep, demo.java, right? So let's open the command prompt and go to desktop. Yeah, there's our demo.java file. So now you have the demo.java file, right? So now you have to compile. What did I say? Which tool do you use to compile Java program? Java C, right? The Java C compiler. Where was it again? It was in the JDK bin folder, right? So you use that compiler Java C, and the input, or you pass. See, you're using Java C compiler, but you have to tell which file you want this compiler to compile, right? So you say, hey compiler, take this file demo.java and compile it for me. What happens after you compile? Does it give you platform specific code, or does it give you any intermediate form, or as in a bytecode? What does it give? It should actually give a bytecode, right? So let's see what happens. Provided there are no errors, that's fine. Do you see this generation of this file, demo.class? So this class file is nothing but your bytecode that I was talking about. So now, if, for example, this program was just 1 5-line shorter, but even assume if this was an actually full-fledged application, okay? So even then, After compiling, you'll get a number of class files like that. So let's just assume that one folder which has all the class files as bytecode. Okay. What I mean is that bytecode you can just copy paste it on a thumb drive, put it on any other platform and any other machine which is running. It doesn't matter which OS it is. You can actually go ahead and run that program. But the only condition is it should have Java installed on your system, right? So that way you say Java is platform independent, right? Because it's not platform dependent. If it was platform dependent, then the platform on which it was developed, only it should have worked only on that platform, but it's not. It's working on all the cross platforms. So this is your bytecode. So this was generated. So now how do you run this file? How do you run this class file? Again, technical purposes we are using as bytecode, but usually you refer to it as class files. Again, don't just keep saying bytecode. You actually call it as class file. So now how do you run the class file? Using another application called as Java interpreter, right? There was another application above Java, see if you guys remember, nothing but the interpreter. So what does interpreter takes input? It takes input the bytecode and it gives the output. Okay, so let's try that one. Java is our interpreter and just give demo.class. So the thing here is, because it's an interpreter, you don't actually have to provide .class because the thing is, Java interpreter only takes class files. So there's, I mean, you can actually include, but then the developers decide it's just no point in having .class explicitly because all it accepts is class files. So you can just omit that one. So you just run this command and wow, that didn't work. Did I forget something in there? For some weird reason that didn't work earlier. So anyway, see, this is the interpreter, and then you just pass the bytecode or the class file to the interpreter, and then you see the output here. Any questions about this process? How did we write the program? The way we saved the program, the way we compiled it, the way the bytecode was generated, and then the program. Any questions about that? No questions?
Waiting for Perry.
Yeah. .java form. Exactly, yeah. .text form, it would be just any other text. If you just save this file as .text, then that is just a text file. But once you save it as .java extension, then it will be identified as a Java source code. Yeah. This is Notepad++. Okay, that's fine. So there's no difference between Notepad and Notepad++. That's just like color thing. Yeah, that's the only reason. Anyways, yeah. You can go ahead and use Notepad++, but then please do not use an IDE for that. Any questions about this? Yeah.
It is actually the encoding format.
Where is it asking you?
Because I have that program on the untranslated, it didn't identify the Java file.
Right here? Those are text formats, encodings, right? UTF-8. Those are text formats. You don't mess with those formats. Those are just text formats. Which editor are you using to write the program? Is this just plain Notepad or what? A plain Notepad, then it should work. Are you saving the file as name.java? .java. The extension is .java or it's still the text? I think we'll see it after the class.
And in the property of that file, that is also
Java. We'll see that after the class. That should be a problem, but that text encoding format is just the text format that is written, UTF-8, UTF-32 and all those things. Yeah, right. Just 45 minutes more and we'll be done. You guys need a break or something? No? No? Okay, that's fine. So, any questions? Final call. Any questions about this program? No questions, right? Again, this is just a flow how it flows. You write a Java source code that is .java file, and then you compile it using a JavaC compiler. And once you compile it, the bytecode is generated, basically, which is .class file, right? And then you give this .class file to Java interpreter, and then it gives you the output. That is how it works, right? So if you have 10 classes, what happens? If you have 10 classes in one file, and if you compile that one file, what happens? 10 class files will be generated, right? See, for example, in this text file, there was only one class. What if this file, demo file, had 10 classes? In that case, 10 different class files will be generated. So which class file will you pass to the interpreter in order to run the program? Exactly. Again, the same thing. The class that has the main method, you have to pass the class. So one thing about the number of classes, having number of classes in a file is, although you can have any number of classes in a file, but only one class should be declared with the keyword public. Okay. Rest of all classes, doesn't matter which Maxis specifier you use, but the class that has the main method should be declared as public. Okay. So this was actually the syntax thing. If you don't if you do anything wrong here, the compiler itself will give you compilation errors. So guys, just I need to keep your attention sometime, guys. So this is one thing. Okay, this program didn't have any syntax errors, but there's something called as naming conventions, which is actually really important. People actually really underestimate naming convention. What do I mean by naming convention? Exactly. And guys, trust me, this is really important because people actually get fired because of silly things like these. I personally have seen many people getting fired because they have messed up naming conventions. Because I know it's simple. It might be silly because all that you did. You also have naming conventions of methods, variables, interfaces, many different things. So when we talk about each new topic, I'll tell you what the naming convention of it is. Okay. So as of now, we just learned what a class is. Okay. How do you declare a class? Why the public keyword? And everything goes inside a class. And then you have a method and things like that. And yeah, that's it for now. Any questions about this? Any questions? No? Okay. So let's finish what data types, variables, operations are. Have you ever worked on these variables and those things? Have you ever used it for your academic purpose or anything? No? Variables, operators. That's fine if you haven't because it's just so easy, you'll figure it out now. So again, What is the data type? What is the data type? Why do you use data types for? To store data. See, if you're writing a program to calculate what, for example, if you're writing, if you're developing a calculator, I'm taking that example because I think you actually have an assignment where you have to develop a small calculator, just 4 basic operations, not the complex one, just addition, subtraction, multiplication, and division. Okay, you actually present user with a small menu, like present 1 for this, press 1 for addition, press 2, and then when I select 1 or 2, then you have to ask for 2 numbers. And once I give them the 2 numbers, you basically have to add them and print it back. So that's a simple application that it actually sounds. But then I'll tell you how to do it. I'll give you most of the part of it. But then yeah, the implementation part, I think you guys have to do it anyway. So anyway, the point of discussing calculator was in scenarios like that, when you want to hold 2 values, right? If you want to add 2 numbers to multiply 2 numbers, at least for some time you have to hold those 2 values, right? That is just one scenario. What I'm talking about is in general, your program actually needs placeholders. I mean, your program actually needs something to hold data, right? At least for some time, variables or your names or your addresses, whatever it is, your program, how does it store? Or it uses data types for that, storing those kind of things. So now why do you have different types of data types? Again, the name itself gives that away. Depending upon the type of data, we use different data types, right? If it's a number, we use different data types. If it's a decimal number, you use different data types, right? If it's character, it's not number, it's a character, right? Word or something, you use a different data type. If you are giving an entire name or address, okay, which you have numbers and letters, then you use different data types. So the whole idea is there are different data types because each data type holds one specific type of data type. So now let's categorize them. You basically have 2 types of data types, okay? Primary data, reference data types, primitive data types, and then reference data types. So let's not bother about what reference data types are, because again, as I've been telling, reference data type is something that you'll understand once we talk about what classes and objects are. I know I'm just repeating myself, but I cannot help it. That is how usually first class of this session is, because there's just too many stuff that comes initially which you don't know about, but that is how everyone learns. That is how the nature of learning programming language is just progressive. You cannot expect most of the things to understand the first class. Just be patient. I'm not trying to get away or something. That is how it works. So anyway, let's not study about what reference data type is as of now. Let's see what primitive data types are. Again, classifying primitive data types, there are 8 primitive data types. What are they? Can you list them? Int, okay, short, long, float, double, boolean, and then char. Right? There you go. Did you get? No, you have something. Wow, there is only 7. And byte, you forgot byte. Byte is another which holds an integer which is just small. Anyways, again, you have 8 primitive data types. The reason you have 8 primitive data types is each primitive data type is intended for a specific purpose. Let's just go through briefly about all these 8 different data types. Again, there's a lot of theory behind this, which is not really important to discuss in this class given the amount of time we have. So you can go check out, like for example, what's the maximum value that it can hold, all those kind of things. Those are just numerical data which you can look up in Google or something. But I'll tell you importances of all these 8 data types. Integers you use usually, it's the most used variable in your programming. You'll always keep using integers, but because it's just a nice trade-off between storage space and access times and all those kind of things. So integer, it just try to store that numbers in integers, it doesn't work. Either it rounds off that number or it doesn't even accept that number in some scenarios, right? Again, that depends in different languages. So anyways, float you use for decimal values, and the same reason why you have double. Just like long, you also have double. Like long is used for bigger integers or larger integers. Double is used for larger decimal values, right? So I think usually they go with double. They don't prefer float, and yeah, they usually prefer double, just like that. And you have a Boolean variable, which the thing with Boolean variable is it can just only take two values. Either it can be true or it can be false, 0 or 1. That's it. Cannot assign anything more than that. Either it's true or it's false, and it's actually used a lot sometimes. And you have a character. These are all works with numbers, whereas character data type is used to store a single character, right? For example, you have all those form applications where you have to fill out your gender, right? So either it's M or it's F and whatever it is. So you use character in that case. So just store a character. And byte is just stores 1 byte of data, can be number or anything, just another trade-off. So those are 8 different primitive data types. You have each slide dedicated for that slide, so you can go through all the slides. And yeah, so those were the 8 different data types. How do you declare 8 data types? Integer, you declare just the form integer, short, long, float. These are actually the 8 keywords that you have to write in order to use this primitive data types. Okay, and usually the most common mistake people do is use capital B here. Do not do that, even though it works. Try doing that, it will work, because Boolean also has a meaning. It's actually a upper class, but again, we'll get to know that in later classes. But again, the usual mistake they do is write capital B. But that's okay, but then I'm just giving you a heads up. So make sure you have all the small letters. Again, this is not naming convention. Don't confuse with that. This is actually the keywords. These are defined this way. This is not because you want to look good. This is because that is how it was described. Don't get confused this thing with naming convention. Okay, so these are data types. This is how you declare to use data types. Should be 8 different data types. Now, what do you mean by variables? Same thing, variables, placeholder. That is what you use to store data, right? So for example, you want to store 2 numbers, two real numbers or 2 decimal numbers. So what do you do? Float A and float B, right? So that is how you declare. Is this a good idea? Float A or float B. Now this is where naming convention comes in place. You cannot do that, right? I mean, it works. It definitely works. If you write something like this, it definitely works. But there are 2 problems with this. The first of all, you cannot start a variable name with a capital letter. Okay, you have to even for example, say if you're writing bank balance, you cannot write bank balance, something like that. You cannot do that. But you can always do this thing. So if you have more, remember, for variable names, the first letter of the first word should always be small. And if you have more than 1 word, then those first letters of the another words can be capital. But remember, the first letter of the first word should be always small, right? So that is one naming convention. Again, if you write capital B, everything's fine, the program works. But if you show this program to someone who's superior to you, that doesn't impress them. That's not going to impress them, because it's not just the way you write programs. So you have to actually, I'm telling you right away in this classes, because most of you are actually starting these things. So you actually get habituated to this thing, because rather than just practicing now and trying to change that habit. So don't overlook that. Please try and implement naming conventions also. So for class, it was what? Camel case, right? Even for the first letter of the first word should be capital, but whereas variable, first letter of the first word should be small, but next first letters can be capital. So that was about the variable. And this is how you declare a variable. What if you want to initialize a variable? What do I mean by initialize? Giving some value to that. So I write float bank balance equal to what? 5,000.23 or something. And because this is a float, this is a decimal value. That is what I mean by a decimal value, right? So you have different variables here. See, these are some examples of the naming conventions. Int, class size, C is small, S is capital and double, my bank balance, B in capital, M are small. And just some two sentences where you're actually initializing those values, right? So any questions about the variables? Just the 820 data type. There are actually two reference data types, which we'll talk later, but yeah, this talk was about just perimeter data type. Okay, so now these are basic operations that you actually have to know. Arithmetic, these are 4 operations: plus, minus, multiplication and division. Let's see if we have that class. Where did it go? Right here, right? So if I want to add 2 numbers, what I'll do? And I is equal to 5 and j equal to 5. Is this a good idea? Is anything wrong here? There is. One of the, I said there was something wrong with, there are 2 things wrong with this, the earlier kind of thing. I said there are 2 things wrong with this kind of declaration. What was the first? I only discussed first thing. What was the first thing? It should be capital. It should be small. Okay, that is fine. But what was the other thing that is wrong with this? What do you mean by B? Because the thing that is wrong with the declaration float B is it just doesn't make sense. Does it make sense? I mean, you might have thought something and written B, but always remember, you are not writing a program for yourself. You'll probably never write program for yourself, right? You always write program for others. So you have to make sure that whoever you're writing for program should understand what you actually meant. You cannot think a lot in your brain and just do little on computers, right? Your program should be self-explanatory. If someone sees your code, even if it's 10 lines, they should make it out what you're trying to do. If that programmer or whoever is reading your program should not have any kind of difficulty, which is actually appreciated a lot. That ability, that ability is, it's not technical, but then again, it's actually appreciated a lot. Okay, so make sure your program, the variable names that you use, the class names that you use, the method names that you use. Do not just write method 1, method 2, x, y, z variables, classes like my wish. Don't write those. Don't declare variables or classes in that names. Make your variable names or class names intuitive. Okay, if someone sees your code, I mean, see, don't you feel happy when you see a code that you immediately understand, right? If you have a hard time figuring out what the guy did, somewhere down the line you just curse the guy, right? I mean, why couldn't have been more clear with the code? Again, one more thing, you can always write comments to make your code more beautiful. You can always, and you can is the wrong word. You should actually. You should always write a lot of comments in your code, even if it's adding 2 numbers. Do not think that, I mean, at least at this point, do not think, I mean, maybe he'll understand. Please go ahead and write. If you're writing a method to add 2 numbers, just write a small comment by writing method to add 2 numbers. That's it. It need not be anything poetic or inspirational, just a line, just adding 2 numbers or something like that. I'll show you how to actually write a code comment. See, again, you have many different forms of comments. You have single line comment, you have multi-lining comment, and then you have a documentational comment. I'll show you document comment once we use Eclipse IDE, but we have single line comment and multi-line comment. What is a single line comment? Double quote. So this is like just 2 variables. That's it. Need not be anything fancy. It's fine. 2 variables is comment. Or if you have a lot of theory to write, if you really like to write, then you can have, instead of putting these double quotes in each line, you can just write multi-line comment. That means just write this thing and then just do this thing. So these are just 2 different types of comments. So again, you have to actually use commenting a lot. This is really, really important. No matter how good your logic or how good your algorithm in your program is, and please, if you have interviews where I don't know how you do your interviews, but if you're having interviews, for example, I have seen interviews. I mean, that's the only way I've seen, because they usually share the screen, right? In a Google Doc, the interviewer shares the screen, and you have to write a code. That is how it works. But if it's the same way that you guys are doing it, make sure you keep writing comments if it's a logic. Okay, because hardly, if you're cracking an interview, hardly you'll probably be given an hour to solve the question, and it would not be more than what, 15-20 lines. That's it. So it's no big deal to write comments for 15-20 lines. It's really important because, see, there are two ways you can make the interviewer appreciate you more. One way is talking to the programmer. Okay, for example, if you're showing demo to someone, don't just keep writing the program because that's just rude. Just keeping calm and just writing the code is just too rude. So at least walk the interviewer through what you're trying to do. So tell him, no, I'm trying to take these two variables because I'm hoping that I can probably interchange the value. Something, just what are you trying to do? Don't just put that in your head. Speak. What you're trying to do, speak up so that interviewer can understand your thought process. And trust me, as I have seen a lot of guys who have done terribly bad at the interviews, but their thought process got into their got them jobs. Because it's not about solving a program. It never is. It is never the target that this guy should actually solve the problem. That is not. I mean, but the most important thing that keep looking for is the way you're thinking about a program, right? Because that particular problem, you solve it, that's fine. But what's the guarantee that you'll solve the problem? But your thought processing, the thing is that you might have been lucky. You might have studied that exact problem in the morning and you are lucky, you solved the problem, that's fine. But that is not the way they judge you. That's the reason they don't judge you based on your how excellently you solve the problem. They look out for how you actually think, your thought process, how you're going about the problem, what factors are you considering and what factors are you focusing on and all those kind of things. So again, I'm off the topic, but that's my habit. So anyways, make sure you put your thought process out in the world. Let them know how excellent you think and how beautiful your mind is. Okay, don't just limit that to yourself. Okay, and yeah, coming back to the program. So that is one way of going back to that point. That is not the only way of letting the others know what you're writing in your code. Okay, the other way of letting other people know what you're trying to do in the code is through comments. Right? If that thing is not happening live, you can always include comments in your program. That is one way of going about it. So yeah, I've shown you two ways of doing comments, right? The other way I'll show you in the Eclipse IDE. It's called as Java doc comments, which is actually really important to include documents commenting. So anyway, those are the four operations. So again, how do you use that? I have two variables. Again, I've said this is just a bad naming convention, int I, and you can always write number 1 or whatever, but being lazy, I'll just put it as I, int j equal to 5, and then what do you do? And I'll write one more variable to store the sum, right? I'll write what k, I won't initialize it to anything, and then what I'll do is I'll say k equal to I plus j. Make sure you have these spaces between the operators. Don't just put it in one from this part because it's all your space. You're not renting it out. This text editor is yours, even though you might not have paid for it. But then don't make the code too, don't just squish everything, because the thing is you can put this entire thing in one line. You know that, right? I mean, you don't even have to put all these lines in. You can just fit in everything in this just line number 3. You can just keep on doing that, right? That doesn't matter. The whole point is to make your code look good. That's the whole idea. And even this column spacing, those brackets, do you see these lines? Even they have a specific meaning. That is called as indentation. You cannot mess that up. You cannot do something like this. I know, trust me, I know this seems like silly, but this is what they actually look out for. I mean, these are the easy ways to deduce that someone is a programmer or not. So, I mean, because if you write code like this, it's not the way how you do. It's not the way how you do. If you have at least written minimum amount of program, you'll be habituated to write code in a certain format, right? So one can, without even asking you a single question, one can even just look at your code and tell your expertise. Okay, so make sure you have this beautiful presentation. That's it. Okay. Again, because the thing is, you shouldn't lose your points based on these things. Technical questions is anyway difficult. Let's not screw our impression based on these things, right? So this is the easier points. We should score on this. So let's go back to this thing. So this integer k is storing what? Sum of I and j, right? So this is called as operator, and these two things are called as what? Operands. Okay. So this, what is the operator? Sum. The sum operation is being performed on two operands, I and j, right? And then whatever the sum is, I'm initializing that to K. So how many operators are here? Two operators. What is the other? Exactly. That the other operator is the assignment operator, right? So you've got I. See, you did I plus J. You got 5 here. But what I'm trying to do, I'm assigning 5 to K. That is one more operation. So yeah, there are basically 3 operands and 2 operators here. So that is one just simple example, and you can make out how to do subtraction, multiplication, division, right? No need to show those things. So any questions about this up until this point? Guys, let me know if I'm speaking too fast or if it's not clear. I have it. It's fine. So unary operators. Yeah, this is interesting. See, these operators are, again, you have different forms of operators. Even operators can be classified into 2 or 3 types. You have unary operators, you have binary operators, and then you have ternary operators. What kind of operator is class? Is it unary, binary, or ternary? What kind of operator is that? Is it unary operator? It's not. It's binary, because, I mean, my bad, I should have told the definitions. The thing is, the unary operator or the binary operator, the way you classify them is how many operands does that operator require in order to do the operation, right? Because plus, if you are adding something, then you obviously require 2 things to add up. You cannot add one thing, right? You need some other thing to add it, right? So that's the reason class is the binary operator. And how about assignment operator? Is it unary or binary? It is binary, right? Can you just use K equal to? So you need another thing. So when you, let me give you a few examples of what unary operators are. Have you ever done incrementing and decrementing, plus plus or minus minus? Those kind of operators are unary operators, plus plus and minus minus. So let me show you. Again, this is actually a tricky part in the increment and decrement operators. I'll tell you those things. Let's do one thing. Int I equal to 5. Int I equal to 5 and K, and then what I'll do is K equal to plus I, right? Now I'm trying to print the value. See, I want to print the value of K. So do I need the inverted commas? I don't. What happens if I put inverted commas is whatever is inside the inverted commas, it will literally print that. So if I write K here, it will just literally print K. It won't print the value of K because it just assumes that K is something that you want to print because you have inverted commas in there. So you remove inverted commas. So now what happens is it assumes that, okay, K is a variable somewhere in the program. So now it goes and fetches the value of K and prints, right? Is there any stupid error in there? Probably no. Anyway, see. So we have value of I as 5. We have another integer K, and then we have incremented the value of I, right, by 1. And then we have K taking that value. So now, let's do it this way. Let's do it this way. I want to show you something. Let's do it this way. So what do you think the output will be if it runs successfully? The output will be what? The output will be 6, right? 6 or 5. Anyways, let's see what happens. So again, whenever you make a change to a program, make sure you compile and run it again. If you don't compile it, then it will, if you're directly running the bytecode, then it will run the old version of the bytecode, right? So it won't reflect the changes. So if you're making any changes, you have to actually generate a newer class file. So you have to compile it again and then run it. That's the reason you cannot directly do Java demo. You have to first compile and then run Java demo. See, what was the value? 6. Why? What happened?
It was incremented the value before.
Fine. Okay. That's fine. What will be the answer now?
5.
Let's see what the answer will be. 6, right? 6. Answer is 5. So what's the difference? I just changed the position of the operator. What's the difference? Exactly. So the difference is the position itself. This is actually really important. See, these are two different operators. This is post-increment operator. This is pre-increment operator. Right? So what's happening in here? Exactly. What happens is it increments. Yeah, exactly. So which operation is performed before? First assignment operation is performed, and then increment operation is performed. In here, first increment operation is performed, and this assignment operator is done. Okay. So how about? So again, you have this two things: logical negation, bitwise complement, and all those things, which are not really important. It just gets really complex. All the shift with bit shifting. But again, we'll come to this in later classes, because I think for this session we might actually do data structures. I don't know, I'm not sure, but still, if you're doing data structures, then we'll see what these things are. So those are again different operators. You can just try at home. Just initialize random variables. Try performing different kind of operations on those variables. Okay, and again, this is the order of precedence. Again, this is just mathematical aspect. This is not programming, but you guys know what order of precedence is, right? BODMAS, bracket off, and then division, multiplication, addition, subtraction. So make sure you see those things again. Just for a reference, you have this thing. How do you perform this? I see a lot of questions on Facebook comments, right? Have you ever seen? Exactly. So again, this is just simple things. The thing is, exactly, first you have to take care of brackets. What do you mean by take care of brackets? You have to keep removing the brackets. How do you remove the brackets? Innermost, exactly, innermost bracket, and then working out your way to the most bracket from the outside or whatever it is. So now, what's the most innermost bracket here? This thing, right? So we perform 10 minus 6 and then 4. So you have 3 into 4, 12, and then 24 by 12 is 2. So again, just in case you come across situations. So these are assignment statements. Again, we already did this. Something in the place of expression, we had what, I plus j or something, and then we valued that expression. Whatever the result is, will be assigned to this variable. For example, if you are calculating the area, you can have these three variables. These three variables, right? Multiplication, multiplication. What's the area of a circle? Pi r square, right? So pi multiplied by radius multiplied by radius again. So you're storing. This is just the demo of assignment statements. And yeah, we already did print statements. And one more thing is, what if you want to print something, a number also here? See, what does this do? This right now prints the value of x, right? So what if you want to also print that? This statement, value of x is, and then if you want to print the value of x, how do you do that? Exactly, you write those things in inverted commas. Okay, so these are two things, right? So how do you associate them? You write. This is called as concatenation operation. This is called as concatenation operation. What this does is, it will take this thing, print as it is, and when it sees plus, it sees okay, there is something else that I have to do. So you can also have another inverted comma statement here. That is fine. But instead of this, what we want to do? We want to print the value, right? So you can just have x. Okay. So what happens if you just write x plus y here? Will this print value of x and value of y? It's not going to do that. Try doing that. What happens? Again, for this class, at least try experimenting with simple programs. I know that Hello World program is just too simple, but try weird things, try doing weird things with that program, remove this thing and try running it, see what happens, because that's the only way you can learn all the, because there are just innumerable amount of errors and things that we can just keep on talk forever. You know, I cannot cover all of these things. But the thing is, if you try and hit some of these things, you can actually see interesting errors. So what you do is you just keep changing weird things. You just take out public, take out static, take out void, and try executing the program and see what happens. If you don't understand the error that was generated, just copy the error, put it in your browser, and then just what do you say, prepare Stack Overflow or something. Again, Stack Overflow is just a blog for programmers where, you know, if you have any question, you post on it and it will just get answered by expert programmers. So again, it's a wonderful resource to know about, and not just errors, but to know about anything. So in specifically, if you want to learn, you can always have this habit of writing a query and then write Stack Overflow next to it or whatever it is. So it will just directly give you the Stack Overflow link of that particular problem. So try doing that. Try removing some keywords and try, you know, different operators or find different variables. Try doing it. What happens? Figure it out. And if you have an interesting error, you'll know something that we already don't know. Right? So that was about the order of precedence, and then we printed the results, and this was, what will be the output of this program? 4, right? 2 plus 2, 4. That is what it will print. There's a reason. Try doing that, what happens? Try doing that in your program and see what happens. Again, are we done here? It's 8:30. Are you guys willing to sit here? Yes, some more time. That's fine. Because thing is, we can cover loops, but then that will be just too fast. Because once we cover loops, you guys can do an assignment, or else you probably won't have an assignment to do. And I mean, I'm not being mean, but because we are meeting on Thursday, right? So there's just 2 months time. You can. Do you want me to go ahead with loops? Yeah, sure. Cool. No. Okay. How about a class on Saturday? Let me just pause this thing. There's no point recording this. So yeah, I'm trying to print this hello world 100 times using a loop, right? So let's try with the for loop. So as I said, there are 3 parts in the for loop, right? The first thing is what? Counter. So I can declare counter outside of the for loop, something like this nj, but then you can do it here. Again, the thing I want to say here is, it's usually they implement counters through INJ. They represent INJ are actually used for counters. So it's not a bad idea in this case to use INJ for counter variables. Okay, that's fine, because usually when someone say I++, J++, the notion is they're using counters. So make sure you do not use INJ for any other purposes. Okay, because I'm not saying that's the only way, but it has been just Java is out for like 20 years now, 95, yeah, it's more than 22 years. So it's just the way programmers have been doing it over the time. They keep doing in all the textbook examples, they keep using INJ for the counter, so that's the way it is. So let's say int I, which is equal to what? 1, right? This is one part. We're done with initialization. This is the counter thing. I'm done. Right? Now, what's the second thing? The condition. How many times I want to loop this for loop? What is the condition? Exactly. So I should be less than or equal to 100. And then for each time I print that thing, I have to increase the value I++. Right? Now, let's try to run this thing. See, that was printing hello world 100 times. So yeah, that's the idea. Or you see, you can come up with any number of logics. You can have 100 here, right? And then you can say what I is greater than or equal to 1. And then you can, for each time, you can decrement the value. So 100, I is 100, 99, 98, 97, and that way you just keep on doing it. So anyways, that's just another way of doing it. So this is one example of for loop, okay? Now, the second, any questions about this? One thing you have to know is how the for loop flow works. All the statements don't get executed one after the other, they don't work. People usually think that this thing executes, this thing executes, and this thing executes, and then it comes into the loop. No, it's not. The way is a little different. How it does it? First, it initializes I equal to 100, okay, and then it checks, it initializes I equal to 100, okay, and then it checks the condition. I is greater than 1, it is, and then it decrements, and then it prints, right? And then say, does this initialization thing works again? No, it does not. If you are initializing it again, then it's an indefinite loop, right? Because for every time you're decrementing one and then you're initializing it with 100, so the loop is never going to end. So the control it flows is, this initialization statement only works for the first time, and then control flow flows like this: condition, decrement, print, only in these 3 items, right? Oh.